Okay, I figured out how to unmute myself, I think. Great.
Manipulator.
Okay, cool. So I'm really happy to be here. Thanks for the invitation, Max and Binta, and thanks for everyone who's here. I this topic is like so important, so I'm just very happy that there are people talking about it more. Um, my talk is not really divided into these sections, but this is almost like what the sections are like. I'm going to introduce, some kind of high level discussion of why causality is useful, what it's good for, and then I'll talk about two relatively recent papers that I've worked on with some co-authors and point towards some future research directions at the end. So uh, we kind of know that causality is important for practical reasons, right? Because we know of examples like this where mistaking correlation with causation makes us do the wrong thing. And I think it's also a bit more salient in machine learning because machine learning is largely a subject that's about like really juicing up correlations, just maximizing using correlations as much as possible. And I think the ML community more broadly is starting to pay more attention to causality for various reasons. But um, here's a few quotes about imagination because I kind of want to get people in a sort of imaginative frame of mind because causality kind of requires that. We've got to imagine the world could possibly be differently than the way it is if we want to talk about things like potential outcomes or counterfactuals. Um, so I to to drive this home, I want to mention a short story that I really love by the author Ted Chiang, and um, this was in his most recent collection of stories. It's a story called "Anxiety is the Dizziness of Freedom," and the basic premise is that there's this device that's like you may have heard of the Universe Splitter app. And the idea is that it's kind of taking this many worlds interpretation of quantum physics and saying that you can do an experiment like that's kind of like the quantum version of tossing a coin. And then depending on the outcome of that experiment, you will take some course of action. But in a parallel universe, a different version of you is taking a different course of action because the experiment turned out the other way in that universe. And the idea in this story is that this device actually has like a sufficient bandwidth of particles that are in a quantum superposition that allows these parallel universes to communicate with each other for some amount of time afterward. And so you could imagine like making important life decisions and then asking a different version of yourself who did the other decision, like, hey, how is life turning out in this other parallel world? Um, but so the story is really good and it kind of explores those human aspects. It's very interesting fiction. But I was also really fascinated by this story from the perspective of just thinking about causality because it's almost like what we really want to do when we're doing a randomized experiment. We do randomized experiments because we can't see the outcome for the same person under treatment and control. If this science fiction story was true, we would be able to do that. So we could see like, you take the treatment in one universe, and you take the control in the other universe, and you communicate between these parallel universes. So this is the kind of hypothetical reasoning from this science fiction story that I think is useful for thinking about the kinds of causal models that I want to talk about today. So causality is really important practically, not just from speculative fiction perspective, because causality is useful for changing the world. We don't just want to predict what's going to happen in the world. We want to actually change what's going to happen in the world. And that's kind of the classic machine learning prediction task perspective versus the policy design and intervention perspective. And this book on the right here is um, a really good book by the philosopher James Woodward, who's making proposing a theory of what we mean by causality, which is about manipulation. This is when we're talking about causality, we're really talking about what kinds of relationships we can use to change the world, to make changes that we want to happen. And there may actually even be a sort of evolutionary reason why that's true. There are other animals that seem to have some understanding of causal relationships. And it makes sense from an evolutionary perspective that an animal with enough ability to reason abstractly that learns how to manipulate the world might have a fitness advantage compared to animals that don't learn how to manipulate the world. So, this idea about manipulating and changing the world could be really closely connected to causality. So I want to connect this to fairness by going into this really classic example of fairness, where the Berkeley graduate admissions example. Um, this is maybe one of the early examples where people used data in a systematic way to show what seems to be a type of unfairness and try to analyze, like, in what sense is it unfair. And it's used as a really canonical example of Simpson's paradox, for example, where a certain relationship can change the direction depending on whether you're looking at a certain level of aggregation or within different subgroups of a population. And one interesting thing about this paper, I think that's less well known, a lot of people are aware of the basic conclusion that the pattern of discrimination in Berkeley graduates admissions was attributable in some sense to which departments applicants were applying to. A lot of people are aware of that conclusion, but not many people are aware the authors of this paper kind of use this language, which, although they don't use the word cause, they are talking about root causes. Like, we've seen some outcome that seems to be unfair. The question is, why is it unfair? Like, when did it become unfair, and what factors made it unfair? And in this paper, they point to factors like socialization and education, and they say that they think the aggregate unfairness in graduate admissions is due to those root causes. So this is a directed acyclic graph that I'm giving as an example to represent the kind of reasoning that I think would be consistent with that paper. Although they didn't, like I said, they didn't use the word cause, I'm now going to be explicit about it and say, let's suppose that there is a causal relation, a causal model, and it might look like this. So a graph like this has variables as the nodes, it has relationships as the arrows, and you can use graphs like this in non-causal ways just to encode conditional dependence relations, but you can use a graph like this combined with an additional assumption that if you intervene on one of these variables, then the intervention also has an effect on variables that are on paths directed away from that one. If you combine the graph with that additional assumption, then you have a model for causation. And this is a very useful model for causation. You can come up with lots of examples this way. You can analyze lots of examples this way. And in particular, thinking about this Berkeley graduate admissions example, there's a few ways that we can interpret this graph. So we can think about it from an intervention perspective and ask, how could we change these root causes that the authors of the paper mentioned, like socialization or education? Maybe we could do something like change the curriculum in STEM subjects and include more women role models in those curricula to try to change. This intervention would then, because of this graph, it would also possibly propagate through and change people's choices of their major. And we might then have more women applying to the departments that have higher admission rates. So that's one way we could interpret this. Another way we could interpret this is a little more speculative. This is a little more like, more sci-fi. This is not something where we can do experiments as easily or possibly at all. And that is to imagine a complete counterfactual. Like, for example, I think about myself. I went to graduate school. I was admitted into graduate school, but I sometimes wonder, if when I was in school, if I had a different gender, maybe I would have chosen a different major while I was studying because of the way that I was rewarded or not, based on what I was studying. And then maybe as a result of applying to a different, having a different major, I might have applied to a different program, and that program might have been one that was more competitive, and I might not have been admitted into graduate school. So I can think about this fact and I can ask myself, is this fair? Do I live in a fair world? One in which, you know, it seems as though if I imagine these counterfactuals, there could be different kinds of outcomes on the basis of some factor that was not necessarily in my control. And this is a sort of luck egalitarianism type of idea that Ruben mentioned earlier. So I have this kind of high level argument for why we should use causality. And it's kind of like, you know, in philosophy of science, we want to do things like bet on sparsity or parsimony or simplicity or something like that. It's not guaranteed to work. So it's a bet. We're gambling. We're saying, other things being equal, I'm going to use this principle and hope that it works. So my claim, my bet is that if we focus on causality, then thinking about fairness can still be useful, despite the sort of critiques that Cassie and Abeba have in the paper that we've all read about merit and just desserts. I think that you can actually bridge these two different views and kind of reconcile them using causal models. In particular, if you try to create a causal model for what are the root causes of differences in merit or qualification or whatever the yeah, that word, whatever operationalization that we have of that sort of concept, um, you can use causal models and you can find like what are the reasons why this algorithm learns that there are, you know, different calibrations of merit scores between different groups. And then because of your causal model, you kind of know, or you have some better idea where to look for interventions, where to look for ways to change this outcome. Okay, so a few other high-level concept or points about DAGs and different modeling approaches to causality. I would say this is just to point out that not everyone uses causal models. There are some objections to them, and I want to kind of be a little inclusive and not just give my only my opinion about them. So Julia Pearl has this idea of a ladder of causation. We've talked about interventions and we've talked about counterfactuals. Interventions are things we could actually possibly do, or maybe even we could talk about hypothetical interventions. Counterfactuals are more like what would have happened if something had been different in the past. So we definitely can't do it. And then I also talked about kind of a more speculative thought experiment version of this, where you could imagine counterfactuals that even at the point of time previously, you wouldn't have been able to do an intervention to change something then. And there's a, you know, different people have different approaches to causation. So there's one kind of strict approach that says we shouldn't talk about causation unless it's something we actually can manipulate. I would say that's a rather narrow approach, and some people adhere to it, and it can be useful to adhere to it because it can actually kind of direct the way you use models, and direct it towards ways where you can actually have applications and experiments and things like that. But I find that a little too restrictive, so I definitely don't follow that no causation without manipulation idea myself. And another useful concept that I find, like this pragmatic idea that statisticians have while interpreting causal models, is that we should always remember that models are wrong. All models are wrong. That's why we call them models. Um, and what we really need to focus on is what's importantly wrong about a model. So I would agree with anytime I write down a causal model, someone will say, here's something wrong about it. And I'm going to probably agree, yeah, I think that's wrong. And then what I want to find out, what I really want to focus on is in what ways is this causal model importantly wrong? Okay, so Hito and Benz wrote this review of Julia Pearl's most recent book where he reviews DAGs. And I think this is a useful paper to read, useful for social scientists in general. I think Imbenz's audience is maybe more like economists, but anyone interested in causality in social science applications, I think, could find this a useful paper. He discusses the relative merits of the DAG approach to causality and other approaches that are already more commonly used in econometrics. And he says he really does think that DAGs are useful. Um, they make it very convenient to express certain things. So they're kind of like a language that has a lot of potential usefulness. But he also points out their limitations, in particular in economics, and probably in a lot of social sciences. It's usually the case that people are engaging in like strategic behaviors or things like that, and in ways which invalidate common causal assumptions where there isn't a useful notation in the DAG framework for specifying that that's happening. So there are various ways that causal models need to be elaborated for like social applications and economic applications where it's hard to write out that specific additional assumption in a DAG notation. So the conclusion is we can't use DAGs solely or only. They're useful for expressing some things, but not everything. And so I'm going to give some examples. And in each of these examples, I want to, again, remember to try to think about what's importantly wrong about them. So what I think is useful about DAGs is that they're somewhat transparent. They make it very clear that I'm stating a certain set of causal relationships, and you can take issue with what I'm saying. You can say, this is what I disagree with you about right here, this part in the graph here. So just to give a few examples, so we could think of a very, very simple DAG where we have a sort of sensitive attribute like race and some outcome variable, and we think there's a direct causal relationship like this. Now, one thing that this mathematical model does not tell us is what is the mechanism of this arrow. It does not tell us what it means, like why there is a relationship here. It does not tell us if there's any other variables in between that are just not in our data set. So a mathematical model that says this does not necessarily say the sort of racist essentialist ideas that would, for example, like a Charles Murray sort of idea. This model does not necessarily say that at all. We could still disagree with this model, but as a formal model, it is not necessarily saying that. And in particular, like something we might have less of a disagreement about would be one like this, where we say if we see some outcome where there's a disparity, instead of saying that it is race which has caused that disparity, we might want to say it's something like racism or the structural relationships that go with racism that have caused that disparity. And then, so the difference between these two models, like what's importantly wrong about them, I think this one is not, it is written in a way that has like maybe some tricky interpretation issues with how we're supposed to interpret the mechanism of causality, or how we're supposed to interpret, in particular, like this doesn't satisfy the manipulation theory of causality, where you could do an experiment where you can like change a person's race. You can't really do that in an experiment. You can change perception of race in an experiment. For example, there have been experiments, and economists I think would be familiar with, Mullainathan and others, I think, where they've randomized like the name on a resume, and the name changes the perception of race, or it correlates with it. But that doesn't mean you've changed everything associated with race. You've changed one variable that's one variable that's related to it through perception. The difficulty with this model is we usually don't get to measure directly the variable racism. Like most data sets are not going to have a way that tell us like how much each individual person has been affected by it. So these were very, very simple graphs, and already there's a kind of a lot of different trickiness in how we interpret them. And part of that trickiness, I think, is part of the usefulness of being able to writing down models like this. when you write a model like this explicitly, then, like I say, we can talk about what aspect of the model we disagree with. Are we disagreeing with, for example, the fact of how this variable is measured in a given data set? Are we disagreeing with the way we're interpreting the supposed mechanism of a given arrow? Um, and then once we move on to more uh, complicated graphs with more variables in it, there's also more kinds of interesting different things we can try to say, like, oh, that was a helpful scrolling feature on my mouse. Okay, so now we can talk about other predictor variables, like more realistic settings where we're trying to predict some outcome using some predictors, and we don't just have like one sensitive attribute, but we have other variables that are, at least at face value, not sensitive attributes. But then we could ask, do these other predictors also depend on the outcome on the sensitive attribute? And then in a graph like this, we can start talking about things like direct discrimination and indirect discrimination. So, for example, if A is gender and Y is admitted into graduate school and X is which department someone has applied to, the question in the Berkeley graduate admissions example is, um, was there an effect through this arrow on whether or not people were admitted into graduate school, or is the effect mediated through their which department they've applied to? So we can start doing causal mediation analysis if we have other predictor variables. And we can also imagine scenarios where some of these predictor variables are what might be considered resolving. This is a terminology from this paper by Kilbertus et al. The difference between a resolving mediator and a non-resolving mediator is basically one of these is assumed to be an allowable reason for disparities in outcomes, and the other one is not. So depending on the specific kind of application, some predictor variables may be considered necessary. Like, for example, it might be something which actually the outcome variable is a medical health outcome, and it could be a health outcome that actually does depend on some sensitive attribute or some mediator between the sensitive attribute in a way where we need to use that information for accurate diagnosis or something like that. So depending on the application, we now have this additional complication to the way we use graphs like this, where we can say for each of these variables, is this pathway from the sensitive attribute to the outcome something that we consider unfair, or is it something that we consider allowable? And we can now start thinking about models that are trying to block specific variables and not necessarily every variable. So this is another kind of way that using models like this allows us to express more complicated ideas about how we're using different variables in these models. Okay, so I think it's useful to have an analogy for me to think about the difference between the mathematical formalism of each of one of those models and the interpretation. So I remember, for example, the difference between the axioms of probability and how we interpret probability. You can have different philosophies for interpreting the same set of axioms, and just like that, in these mathematical models that I've described in each of these examples, the models are simple. They're too simple. They're wrong, right? And then we can have different interpretations of them as well. And none of those interpretations are actually necessary, because the axioms are just the axioms and they don't come with the interpretation. That's extra. So the interpretation involves more things about how we believe the world works, and whether we believe that a given variable in our data set is like a real fact about the world, or just something we happened to be able to conveniently measure and stuff like that. That's all important information, and those are all like directions in which to improve models like this. So now I want to talk quickly about two papers that I've worked on recently that are applying models like this in ways that I think are interesting and are trying to make them more accurate, less wrong. So in this one, this paper was this paper will appear in a new conference, a relatively new conference on foundations of responsible computing, and it's about intersectionality using a causal modeling framework. And there's been fairly little work in this area. There's a few citations here, and there's a few more in our papers. But you can kind of get the sense from a couple of the examples that I showed on previous slides that if you start adding more sensitive attributes into your graphs, that you could complicate these graphs in ways that might be interesting and useful for talking about intersectional fairness. So we'll consider an example with multiple sensitive attributes like race and gender, and we'll think that there's a variety of causal relationships between those sensitive attributes and some potential mediating variables. And now that we have this multiple sensitive attributes, there's also a possibility that like some of these mediating variables could be considered resolving, and they could be considered resolving for one sensitive attribute but not another, for example. So there's a growing kind of flexibility to the number of different complications these models can have to try to make them more realistic. So here we did the synthetic example we call the moving company example. The idea is there's some company that's trying to hire applicants, and the applicants have to take some weightlifting test that's considered a necessary qualification for the job. So in at least in U.S. employment law, companies can use this sort of legal defense that says if something is a requirement for doing the job, then even if there are disparities on the basis of that thing, they're still allowed to use that thing because it was a requirement. So the idea that we have in this graph is that our race and gender sensitive attributes both might affect this mediating variable, and both might affect this sort of hiring score. And then these scores will be ranked, and then the top candidates will be hired. So that's how this idealized moving company plans to use this data. And so we can then apply this causal modeling notion of fairness. In particular, we're going to use this graph here, same graph on the previous slide, and we're going to look at the case where we consider the weightlifting score a resolving mediator. So just assume that the company is actually allowed to use passing the weightlifting score as a requirement for hiring. And then in this little toy model of the world, we've generated data in which there is a relationship between the gender variable and the passing the weightlifting score. This is just a toy model. This is not, again, meant to be any sort of statement about the real world or the reason why such a relationship would exist or its meaning. And then if we look at here, we're showing the outcome in terms of what the proportion of applicants who are hired from each of the intersectional subgroups, where we're looking at sort of binary sensitive attributes on the basis of gender and race. Again, just a simplification for this toy model. And so the bottom row is showing the original ranking that doesn't do any sort of fairness intervention. It's just if the company was allowed to just sort the Y variable and hire the applicants with the highest Y score, the bottom row shows those results, and then each column shows the number of applicants who are hired. So the top row shows a quota system that is based only on race. So this would be the sort of, you could imagine this would be like the simplest thing that you would try if you didn't have any causal model. You are trying to be fair with respect to your sensitive attributes, but you knew that the weightlifting score was still allowed. You could use a quota system on the basis of race. And the middle row is showing the results of using our method, where we model the causal relationships, and we use, again, we treat the weightlifting score as a resolving variable. So the point of this example is not to say, look, our method is correct and the other methods are wrong or anything like that. The point of this example is just to show this is like the kind of elaboration that you can do with these models.
Can I just ask a quick clarification question? Like, what's the difference here relative to something like, say, predictive parity or one of those notions? Like, how does the causal interpretation change the notion of fairness here?
Okay, so predictive parity, I'm not sure. It's been a little while since I've thought about this, how this would relate
Or
to predictive
calibration, but
parity.
like basically the basic idea that unequal treatment based on X is legitimate. And so group differences that are explained by X are okay.
Yeah, that's a good point. That would be maybe another interesting way of plotting the results here. We just showed selection rate, which is a demographic parity measure, rather than like a calibration. So I think you could maybe you could like invert the plot to try to understand calibration. But
I'm not making a case for calibration. I'm just like
yeah,
wondering conceptually whether there's any difference between this or whether it's just about the interpretation of the numbers as opposed to.
right. So then, okay, and this is actually getting back to something a point I was trying to make a little bit earlier about how um, I think that causal models can be used to think about if we're trying to if for example y is like the idea of merit for this example, like it's their hiring score. Um,
I guess X would correspond more to what I would think of as merit, right? And Y is then the hiring decision or something.
No, the hiring decision is going to be based on a ranking of y. So y is x is like a predict one of the inputs into a score, which is like the merit score. And we can, I suppose, like a way to imagine how such data might be generated is that they're also interviewed by several hiring managers who each assign them some score. And so these hiring managers, if they discriminate directly on the basis of race or gender, then those would be these direct effects of these arrows here. And then, each candidate would have an average of like what was their weightlifting score and what was the subjective rating by the hiring managers. And those would be combined into this score Y, which is like the company's idea of merit. And then they would hire the candidates that have the highest Y scores. So to abstract away from ranking and just think about merit, like maybe this other graph is another sort of example. We could think of you're trying to predict merit or something like that using whatever predictor variables are available to you. And the point of this idea, this notion of using causal models, is that it allows us to say such complicated things about how the relationships between different predictor variables and merit should be modeled, and how different of those variables might depend on different sensitive attributes in different ways. And each of these paths could also be considered like resolving or legitimate or not. And so there's like a combinatorial explosion of number of possibilities that you could say a graph like this defines a notion of fairness, depending on which pathways you choose to be considered resolving and things like that. So you could try to apply this notion to something like merit and say, well, our goal is to construct a notion of merit which is not a causal consequence of the sensitive attributes in some way. Like we want to block certain causal influences of the sensitive attributes on the estimated merit score. Does that kind of get at what you're saying?
I guess I'm still slightly confused whether to just think of this as a refinement or a way of picking among existing fairness criteria as opposed to a conceptually different one, right? So like because I would think of a lot of the existing fairness criteria as something like you have some notion of merit, say, I don't know how productive you are for an employer or something like that. And then upon the conditional independence of protected group and your ultimate decision, like hiring.
Mm-hmm.
And I'm wondering whether this generates anything different than that, or whether it's really just a way of choosing or like elaborating what's the thing that you're conditioning on.
Mm-hmm. So I like, my own opinion is that anytime people are doing something which they claim is not causal, they're just not making their causal assumptions explicit. So I would say, yes, I agree with you on the basis that I think other notions are implicitly causal. And so there is like some causal, there is like some model that corresponds, the causal definition with that model corresponds to the notion of fairness that someone is proposing, which they claim is not causal. Um, so I'm kind of saying this as an opinion. Like, again, I'm not actually trying to convince everyone to explicitly use causal methods all the time. That's not like that's not one of my major commitments. All right. Maybe there will be more questions closely related to this when we come back towards the end. So let's move on for now. And just what I want to say about this approach is that I think it shows how causal models can be a useful formal language. Like, we're able to start talking about some examples involving intersectionality and fairness with multiple causal attributes or multiple sensitive attributes, multiple mediators, and so on. But then the other thing that this shows is that it's empirically, like in a real application, extremely hard. That's why I showed you a toy example, where it was in particular a simple toy example. Um, Causal mediation analysis is a hard problem. If you have multiple mediators, if you have multiple causes, it's a very hard problem. And I think this means, to me, this doesn't mean that it's a limitation of our approach specifically. It means that intersectional fairness itself is a very hard problem. And maybe advances like methodological advances in causal mediation analysis with multiple mediators and multiple causes could then be leveraged to study intersectional fairness. All right, so moving on to the next paper I wanted to talk about. This is now more closely related to the theme of the workshop, where we're trying to think about interventions and not just like changing the way we compute a prediction, but going out in the world and doing something in the world. So again, going back with what I was saying about when people claim they're not doing causality, they really are. We're going to use predictions to make decisions. That's why we care about those predictions anyway. So even when people say they're only doing prediction, they probably actually care about causal relationships too. But now I'm going to explicitly model an intervention. And so
the heads up, we're close to being out of time, right?
This will be pretty quick. So I'm going to design a optimal policy or intervention. I want to do this. So I'm going to model the causal effect of the intervention, and I want to relax a common assumption in causal modeling. This is the stable unit treatment value assumption, or the assumption of no interference, where you say that if one unit or person gets the treatment, that doesn't affect someone else. It only affects them. I want to relax that assumption. I want to take that assumption away because I think that in fairness applications, that assumption is going to be generally wrong. In fairness, we're often talking about things like allocating a scarce resource, where one person getting the resource actually does potentially affect someone else who doesn't get it. So here we're going to explicitly model interference in the causal relationships. So Z is our intervention. We're going to say that, for different individuals, Z can be 0 or 1. It basically corresponds to giving some additional resource to unit I if Zi is 1. And so I can then explicitly model causal relationships in my graph model for causation by saying that one individual getting this treatment, it might also affect some other individual's outcome. And in a given, whatever your application is, your interference structure might change, and there are different approaches to using different kinds of interference structures in causality. I'll say slightly more about this on the next slide really quick. But then what I'm going to do is I'm going to try to make an optimal policy, like allocate my fixed budget of resources to all the individuals in a way that maximizes the expected outcome. So this is an outcome that I'm thinking is a positive, good thing. My intervention is trying to increase this total outcome. And the interesting thing here is that I can increase one unit's outcome by an intervention that might not affect them directly, but might only affect them indirectly. Then I'm going to also have a fairness constraint in this optimization problem, which we call bounding counterfactual privilege. And the constraint is here. And this is basically saying that I don't want my I don't want um, my intervention to benefit people who are already doing better on the basis of their sensitive attribute. Like I don't want my intervention to just result in the rich getting richer. So this is showing the results of this on an application. This is a partially synthetic application where we used some real data from schools in New York City. And we thought that the intervention would be something like giving a different school some additional resources. And without the fairness constraint, the optimization problem allocates almost all of the additional resources to schools which are majority white. So the outcome here is like the percent of the students in that school who apply to go to college. So we're trying to allocate some additional resources to some schools in a way to increase the portion of students who apply to go to college. And without any fairness constraint, solving the optimization problem using the observed relationships, the optimization problem says give all the additional resources to the schools that already are doing well. Basically, it's a rich get richer problem. We put this fairness constraint in, and now we have an allocation that's more evenly distributed among schools. So there are some schools that are majority Black and some schools that are majority Hispanic who are now also getting the additional resources. Okay, I gave a couple ways that we can elaborate on these super simple causal models through having multiple causes, multiple mediators, and thinking about intersectionality, and through um, modeling interference. And then there's a whole bunch of additional ways in which we could use causal models to elaborate on how we're modeling uh, certain kinds of sensitive attributes that we believe are social constructs that might themselves be consequences of other things and not only something that we'd think of as a cause. And so there's future work. I have ongoing work with some students working on some of this. Um, a few closing thoughts about merit and the things we really care about. The fundamental problem of causality is we don't get to observe everything we want to observe. And I think even if we say we are not talking about causality, that's also true. We usually don't get to observe or measure the things we really care about. We usually are trying to predict some outcome variable that's just the variable we happen to have. It's not the thing we really genuinely care about. And if we could measure the thing we really genuinely care about, we'd probably stop caring about it soon thereafter. These are some of my excellent co-authors who deserve all the credit. And thank you for listening. And do you have any questions?
Thank you. So I think Peter had a couple of questions. Peter, do you want to unmute yourself?
Yeah, can you hear me? Joshua, thank you. That's a really interesting talk, and it's really thought-provoking. I have two questions which are somewhat related, and I'm going to try and summarize them quickly. Although this stuff is kind of hard to summarize quickly, so I'll give it my best shot. So the first question is, if I understand your earlier claim right, that any discrimination analysis is sort of inherently causal, though people might not make sort of the necessary explicit causal assumptions. What I'm wondering is your view from that sort of when we write down a DAG, which I think is generally, I agree, helpful for thinking through these problems, that we have to think of race, for example, as a cause, as a non-manipulable cause? Or can we just think of it as sort of a characteristic which is correlated with qualification, and that sort of leads us to some conditional on qualification analysis, perhaps, if that's your view, or do we actually have to think of it as a cause? And the reason I ask that is, I'm sure you're aware, this is sort of my second question, I'm sure you're aware that there's a sort of concern or controversy perhaps of using sort of causal approaches to discrimination. I think of Lily Hugh and Isa Kohler-Hausman as sort of leading critics in this field who think of it as kind of strange to think of race as a non-manipulable cause, given that race is sort of this highly social construct, complex object, and it's not really clear what to think of as a counterfactual Peter who's not white. So anyways, that's sort of a rambling series of questions, but I'm very curious your thoughts on this question of the controversy surrounding, treating race or other protected characteristics as a node that has causes in a graph when you can't manipulate it, and particularly what you think of this critique from I think this is mostly from philosophers and from the legal side. So thanks very much for considering that question.
Yes, absolutely. I'm familiar with this line of work, and yeah, I agree with a lot of it. So what I would say about it is I think they've identified things that are wrong and that for specific examples might be importantly wrong. And then the question is, how do we make a model or an approach that is then like less wrong on that important dimension, right? So to me, this does not mean that causality is like the wrong concept to use, or that causal models are necessarily pointing us in the wrong direction on certain kinds of applications. Um, it might mean that one particular causal model or one particular interpretation of that causal model is importantly wrong and like leading in the wrong direction. And I would say like any kind of tool, they can be used in ways that are bad and harmful. And so that's why when I was talking about some of those models, I gave like a lot of disclaimers, because I don't want people to take models that have importantly wrong interpretations and use them in ways that then lead to those wrong interpretations. Then the only two last things I would say about it really quickly, I think that you can elaborate on causal models in ways to make them more consistent with those critiques. That I don't think that, and so also like the second thing is that I don't think the critiques are necessarily about causality uh, for the same reason, because I think you can make a causal model that's consistent with it.
Okay, thanks. Thanks very much.
And maybe also going to ask a slightly incoherent follow-up question, which is kind of half conceptual, half political, I guess. Like say we observe in a society that, I don't know, income is correlated with skin color or something like that. Say, I don't know, or white people make more money. And I guess I'm wondering what is gained by taking this observation. It's just purely an observation of inequality or a correlation, and somehow teasing apart, calling it causal, and looking at mediators along the way and calling some of them legitimate, and coming up with ways of legitimizing that inequality, as opposed to just saying we observe this inequality and we probably should do something about it, without trying to rationalize it through some notion of merit or other. I don't know, yeah.
So my answer here has to also like go far outside of the kinds of models that I've shown as examples, because the answer is related to examples. There are these really interesting commonly used counter examples, like Friedman's thermostat. That the idea being that you can observe some things that appear to have no correlation whatsoever with each other, but one is actually like a direct cause of the other one. So I think if you're just observing correlations and disparities, and you then you set about trying to reduce the disparity, like, because whatever else you think about, you don't necessarily have a causal motive for doing so, or you haven't thought about it that way. You just don't like that disparity. You want to reduce it. And then the question is, you're going to design some interventions to reduce it. How will you know if these interventions are going to work, what they're going to do, that they won't
But
do
at
the
that point, I'm
opposite of what
talking
you want?
about the effect of the interventions, right? At that point, I'm not talking about the effect of race anymore. And I'm saying, is my redistribution or my educational policy or whatever it is effective?
Yeah. And then, so there, I think like the questions are related, because I think understanding why there is a disparity when you look at different racial subcategorizations, like the reason for that created that disparity might be important for understanding how you can change it. It might not be it just might not be effective. I don't also
But that's a
I
separate argument from the normative evaluation, no? Right? Like one is saying, how do I evaluate the ultimate arrangements or my choices and or my policies or whatever it is, and the other one is, how is a particular policy going to affect that evaluation, or like what are the mechanisms that are generating inequalities and so on. But we're conceptually separate, no?
I guess I don't see like I don't actually really distinguish between. So for me, there aren't really like scientific questions that are not normative or normative questions that are not scientific. Um, like I can't disentangle them completely myself. So like I can't think that there is a solution to one of these that doesn't depend in important ways on the other part of it.
I guess it's sorry, I'm going to stop after this, but to me, it's different to say, oh, it's okay that white people earn more because they're better weightlifters or something like that. Um, it's different from saying, oh, if that's somehow a pathway that I can intervene on and that I have, I don't know, maybe a weightlifting policy. I don't know. You see what I'm saying? Like one is
Yeah.
about rationalizing the inequalities, the other thing is about intervening on them.
Yes, yes. Okay, so this is I maybe I forgot to say like part of the my own like approach a goal of using these ideas is it's I need to make it more explicit rather than implicit. I don't like the resolving mediating concept. I would basically be extremely strict about which applications I think a given variable should be allowed to be considered resolving, and I would basically only want to do that for things where I think it's like there is really a certain medical reason involved. Um, and like aside from that, I would essentially never use resolving mediators. So like I'm kind of giving away that I have this ultimate goal, which is political, which is to convince people that um, until they've arrived at a notion of merit that has been like fully adjusted so that um, there aren't disparities in their notion of merit, then our work isn't done yet.
Thanks.